Okay, and so today we are going to return to seeing can pigs fly to leave insert probability. We're going to look at the introduction and permutations, which is linked here. But permutations basically it means arrangements. So here we go. Okay, so just to remind ourselves, well, the fundamental principle of counting is something we've had since we first began probability, and so it basically says that here if we have m items and we have n items, well, that gives us m times n possible choices. Okay, so say for example we were at a restaurant. You decide that you're going to have in fact we're going to go to the Chinese in Tyrrellstown here, so we've decided you're going to have one starter and one thing from the house special dish. So how many possible options do you have? Well, as you can see here, we have 2, 4, 5 starter dishes. So that's 5 options here multiplied by, and over here in the specials, we have 1, 2, 5, 6, 7 options here to choose from, which means you have 5 by 7, which is 35 possible choices for your dinner, just taking those 2 things from the menu. Okay, so that reminds us of the fundamental principle of counting. Okay, so this again would be a typical problem we looked at in junior cert. So how many possible ways are there to arrange the word maths? So using the letters. So say for example we would have, well, there's 5 different letters in the word maths. So we'd have 5 different boxes. We don't want to repeat any of the letters. So in this first slot here, I have 5 different possibilities to fill into it, because I could use the M, I could use the A, the T, the H, or the S. So that gives me 5 options from here. Now, one of those options are already used in this box, which means I now only have, say for example, I had used the letter T. Then here, I'm only going to have the letter M, A, H, and S to choose from. So I now have 4 options. Say for example here, I use one of those, I use A. Well, then that means I only have M, H, or S to choose from, which means I now have 3 options, and so on. And then I would have 2 options, and then only 1 option left to go into the last box, which means if I am arranging the words, the letters of the word maths, well, I have how many different possible arrangements? Well, 5 by 4 is 20, times 3 is 60, times 2 is 120, times 1. So that means there is 120 different ways to arrange it. Now, this sense of multiplying 5 by 4 by 3 by 2 by 1 is called a factorial. Okay, so I'll just put that up here. And so n factorial is the same as n times multiplied by n minus 1 multiplied by n minus 2 multiplied by dot 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 all the way down as far as 1. Okay, and so that is called n factorial, and its symbol is an exclamation mark here. So for example, if we had 7 factorial, we would write that as 7 and the exclamation mark, and that's the same as 7 by 6 by 5 by 4 by 3 by 2 by 1. And that is equal to 5047 factorial. But most importantly, the quick way to do it. So here, for example, if we want to do these 2 questions on the calculator, well, the first thing we'd press here is our 5, and then we press this button here, which has the exclamation mark, the factorial, and we'll get that on the screen, and then simply press our equals and we get our 120. Or again, if we had the 7 factorial, we would simply obviously AC there to clear that, and very simply we'd be pressing our 7 here and then up to our factorial and equals, and we would get 5040. Okay, so that's our factorial button on our calculator. And just one last thing about factorials, very interestingly and very important to remember, that 0 factorial gives us an answer of 1. So try that on your calculator for yourself, but don't fall into the trap of thinking it's 0. 0 factorial is always 1. Okay, we're going to look now at permutations, and permutations basically means arrangements. So how many possible ways is there to arrange a certain amount of items, etc. Okay, so permutations always means arrangements. So our previous example with the letters of the word maths, and we were rearranging them, we discovered they could be arranged in 120 different ways. So that's a permutation, or it's looking at how many different ways certain things can be arranged. Okay, but if we want to look and say, for example, we said if we'd n distinct items, then obviously we can arrange that in n factorial ways. However, say if we have n distinct items that we want to arrange, but we want to arrange them or of them. So let's arrange or of them in order. We have this rule that says that NP, so P for permutation, the number of ways that this can be done, so NP or, written like that, with the N as superscript and the or as subscript, and that is equal to this rule here, which is n factorial over n minus or factorial. Okay, so we're going to look at it, for example. Say, for example, we have a question like this. Okay, so here we're asked, in how many ways can the letters of the word counter be arranged, taking them 3 at a time, and no repetitions are allowed? So that means here I have 3 spots, and well, what do I have? I have 2, 4, 6, 7 letters available for the first one, so that's 7. In the second one, if there's no repetitions allowed, we have 6 spots, and in the third we have 5 spots. Okay, so 7 by 6 by 5, and that is the exact same as 7 factorial over 4 factorial, which is what we've just seen in this formula here. So our 7, and then 7 minus 3 gives us 4, which is this here. And the very quick way to do that on our calculator is here we pick our 7, and then very important, we go to this button here. So we can see it's above the multiplication sign and it's in yellow. So we'd press shift and multiplication sign, and then we would press our 3. So NPR, so 7, picking 3 of them, or 3 different types of permutation, gives us an answer of 210 ways. Okay, and so you could try that out here. 7 by 6 by 5 will give you that. 7 factorial divided by 4 factorial will also give you that. And why is that? Just very briefly, if we had 7 factorial here, basically, that would be by 6, by 5, by 4, by 3, by 2, by 1, and over 4 factorial, which is 4 by 3, by 2, by 1. And we can see, well, the 1s cancel, the 2s cancel, the 3s and the 4s. So these two things are the very same thing. Okay, so that's just a little by way there. But basically our So our most important thing though that we're taking from this is basically any question that we have where it says arrangements, we know we're going to use this NPR button, which we see here when we press shift and multiply on a Casio calculator. Okay, but its formula is also available like this. So NPR is the same as n factorial over n minus or factorial, and we've seen exactly why that is, okay, in this byway there. Okay, so we'll just do a quick example here. So the question here says how many numbers between 500 and 1000 can be made from the digits 2, 4, 6 and 8. Well, the first thing we know, if it's between 500 and 1000, it has to be a 3-digit number, okay, because we can only go up as far as 999. Okay, it's made from these digits here, so actually we could only go up as far as 888. And so the first thing, if it's between 500 and 1000, well then it has to begin with either 6 or 8, okay? So that is the first constraint, and it means that basically we have 2 options in the very first place. So let's look at the other parts to the question. So it says here in part 1, if no digit can be repeated. Well, if no digit can be repeated, I've had 2 options here out of the 4 numbers for the first spot. I've used one of them, so 4 take away 1 means I have 3 options left, and then 3 take away 1 means I have 2 options left here. So 2 by 3 by 2 means that I have 12 possible numbers. Okay, so that's my answer to part 1. In part 2 of the question, well, we still have that same constraint at the very first position, because the number has to be between 500 and 1000. So the only possible options, maybe I'll write them in under it this time, are 6 and 8. Yeah, I'll just write them in here in yellow. So 6 and 8 could go into there. This is part 2. And into the next place, well, digits can be repeated. So in here, I could have 2, 4, 6 and 8, and here I could have 2, 4, 6 and 8, which means in this position I have 4 options, and here I have 4 options. And so in part 2 I could make 32 different numbers between 500 and 1000 from the digits 2, 4, 6 and 8. Okay, so that's my answer there. Just rewriting my possible options here. So 6 and 8, depending on which I used in the first one, I could have had 2, 4 and then either 6 or 8, and then obviously whichever 2 were used could no longer be used here in the last place. Okay, all right, so that's the first example. Let's have another look at a quick example. Okay, so here we have been given the word leaving, and in part 1 we are asked how many ways are there of arranging the letters if there are no restrictions. Well, in the word leaving we have 2, 4, 6, 7 letters, no restrictions, so that's 7 by 6 by 5 by 4 by 3 by 2 by 1, which we know as 7 factorial. We put that into our calculator and we get 5040 ways. In fact, we did it earlier. Okay, so that's our answer to the first one, but just again, no restrictions, so it was just plain and simple factorial. Okay, part 2 then says, what if they must begin with the letter N? So here we've part 2. So with these questions, it's often very useful to draw out your spaces. So 2, 4, 6, 7. So here in box 1, we have one option. It has to be the letter N. So that's, we'll write the N down underneath. Okay, which means I am left with 6 options here. And then 5 options, 4, 3, 2, 1. So we can see that has turned out to be 6 factorial, which we'll just write down here. So 6 factorial, which is equal to 720 ways. Okay, and again, just doing that as the factorial option on your calculator. So that's part 2. Part 3, if they must end with a vowel. Okay, well, so here we are. So it must end in a vowel. Well, we have E as an option there. We have A and we have I, which means we have 3 possible options here. And I suppose always important to note that wherever our restriction is, so here it's the end place, that's what we begin by filling first. Okay, and so we've 6 spots left. We also have 6 possible letters. So we have 6, 5, 4, 3, 2, 1, and so they're all multiplied together. Okay. So basically, if we rewrite that again, we can see we have 6 factorial multiplied by 3. And so that gives us an answer of, well, 6 factorial we saw was 720. So 3 times that is 2,160 ways. Okay, so that was part 3. Okay, so here in part 4, we are asked how many ways there are if the 3 vowels must be together. Okay, so we're going to draw out, and around our last 3 issues, I'm going to draw one box to show that that's one option. So here I have now 1, 2, 3, 4, 5 boxes, which means here I'm going to have 5 by 4 by 3 by 2 by 1. So that would be that, which is 5 factorial. But inside in this box where I have my 3 vowels, so A, E and I have 3 possible ways, because I could have 3 options for there, 2 options for here and 1. So 5 factorial times 3 factorial is how I get my answer there. So notice again with this restriction, I place them all together. I'm told they must be together, so I put it in. I treat it as one specific letter. Okay, and so I multiply those out, and that gives me 720 ways. Okay. Okay, so here we have in part 5, we're told L and N must be side by side. So that's 2 letters, and we're putting those into one box again. So here I can see I have 1, 2, 3, 4, 5, 6 gaps, because again I'm treating this as one option. So here that's going to give me 6 factorial, and then in here, well, I have 2 spaces, so that's going to be multiplied by 2 factorial. Why? Because I could have L or N, and then I could have NL, so that's 2 different options there. So then multiplying that out, and that gives me 1,440 ways, using again the factorial button on our calculator. Okay, and so then in the last part, in part 6, we are asked if L and N must be apart. Well, in part 1, we worked out what was the total amount, which was 5,040. Or I suppose even before we write that bit down, let's remember our rules that P of A plus P of not A have to equal to 1. Okay, so the event not happening is 1 minus the event that it does happen. So we should remember that, our subtraction method. Okay, so here, that's going to be, well, our total probability, or our total ways of this happening, our total number of possibility was 5,040 ways. We worked out in part 1. And now we want L and N to be apart. Well, so we're just going to subtract the ways that we worked out here of them being together. So minus the 1,440. And that gives us 3,600 ways. Okay, so pause this, go back over any of it if there's any bit that you need to just look at again, and make sure that you write all of these notes into your copy. Okay, so one more example. We're asked here in this question, how many even numbers between 500 and 1000 can be made using only the following digits? Well, so here, if it's to be between 500 and 1000, it must begin with 5, 6, 7, 8 or 9. Okay, the other important part for us in this question is that it's even numbers, which means we're going to have to break it down into two different sections or parts of the answer. So the first case is if it begins with an even number. Okay, so begins even. And so the two numbers between 5, 6, 7, 8 or 9 that are even are 6 and 8. Okay, so they're those bits. Okay, anyway, the other part is we know it's a 3-digit number. So if it begins even using a 6 or an 8, that means I have two choices here. Okay, so then the other bit of the restriction that I look at first before I fill in the middle value is, I see here if I have to end even. So the options for even now would have been 4 and then the 6 or the 8. So that gives me two choices here again. So I have two spaces used up. I had a total of 1, 2, 3, 4, 5, 6, 7 numbers. 7 minus 2 leaves me with 5. And so I have 5 there for the middle, which gives me 20 different arrangements. Okay. Okay, and so now we'll have the case where it begins odd. So if it begins odd, well then we have 3, we have 5, 7 and 9 as our options at the beginning. And again, we have 3 different things. So here we have 3 options here, and they are 5, 7 and 9. It still needs to end even. So our possibilities for our ending are, of course, our 4, 6 and 8, which means I have 3 options here. And so again, 2 numbers have been used up in our restrictions. So 7 take away 2 leaves 5 numbers here for our middle digit as the possibilities. So now we have 3 5s 15 by 3 is 45 different arrangements here, which means, similarly from our rule from probability in junior cert, that we just add the 2 arrangements together, or the 2 probabilities. So here that means we have 65 possible arrangements of 3-digit numbers that end evenly between 500 and 1000. Okay, so again, let's make sure that we take down this example into our copy.